trace of matrix. See, always trace is existed for square matrices only. Each and every square matrix is going to have trace. Why? Because just I will say that is trace always is going to be represented with a TR of A. Sometimes you will write as in small letters also. Always if you are writing like this means indirectly that is going to be trace. Trace of a matrix is always is going to be sum of principal diagonal elements. Already we said diagonal elements are nothing but principal diagonal elements is always are going to be existed in square. The elements which having row number and column number both are equal, that elements are going to be say principal diagonal elements. Here the sum of principal diagonal elements, the principal diagonal elements square matrix exist aithe ante compulsory square matrix ne principal diagonal elements untai, vere matrices lo undavu. Indirectly trace kuda ee principal diagonal meedane depend ayindi kabatti trace అనేది కూడా స్క్వేర్ మ్యాట్రిక్స్ కే ఎగ్జిస్ట్ అవుతుంది. ఈచ్ అండ్ ఎవ్రీ స్క్వేర్ మ్యాట్రిక్స్ ఈస్ గోయింగ్ టు హ్యావ్ అ ట్రేస్. జస్ట్ ఐఎమ్ టేకింగ్ అన్ ఎగ్జాంపుల్ దట్ ఈస్ A equal to, just I am taking 3 by 3 matrix. Why? Because our syllabus up to 3 by 3 is there. If 2 by 2 is nothing but very easy, here the trace of this matrix, if A equal to like this, then trace of here trace of A is nothing but simply the addition of principal diagonal elements. Here the principal diagonal elements are going to be 1, 5, 9. Simply 1 plus 5 plus 9 is going to be what? Trace. See, we can write the properties here. The properties of trace of a matrix is indirectly always the trace of A plus B always is going to be, we can write trace of A plus trace of B. Nothing but to find the trace of A plus B matrix, if you know trace of A and trace of B, we can say directly without finding A plus B matrix. If you know trace of A, trace of B, we can say trace of A plus B matrix. Same as trace of A minus B always is going to be trace of A minus trace of B. By using these properties indirectly, for suppose one more we can write trace of Ka equals to, we can write K into trace of A. If we know A matrix trace, we can say Ka matrix trace. K always where K is going to be, where K is indirectly is a constant. Right, we'll see indirectly trace is nothing but always sum of principal diagonal elements. Principal diagonal elements square matrix lo తీసుకుంటాం, ఆ ఎలిమెంట్స్ ని యాడ్ చేస్తే వచ్చేది ట్రేస్. సింపుల్, వెరీ ఈజీ, రైట్? బేస్డ్ అపాన్ దిస్ యూ విల్ గెట్ problems indirectly. These are the properties you have to learn. Here by using these properties we will see some other problems here. Okay, let's see the problem based upon trace. Okay, let's see this. In these problems here you are asking trace of A plus B. Given A and B, here A matrix is 2 by 2 matrix and B is also 2 by 2 matrix. After finding A plus B also you can say matrix. If you write A plus B, you will get directly one matrix. That matrix trace is going to be your answer. But we can write directly trace of A. What is trace of A here? Simply adding these two elements. 1 plus 1 is nothing but 2. Here trace of B is what? 2 plus 5. 2 plus 5 is nothing but 7. Simply here the principal diagonals are going to be 2 and 5. 2 plus 5 is nothing but 7. Always the trace of A plus B is going to be trace of A plus B equal to here trace of A plus trace of B by using the properties. That is 2 plus 7 is nothing but 9. If you after finding A plus B matrix also you will get a same answer. Like some here you will give the matrices trace, then you will ask the trace also. For suppose I am writing one more question here. If trace of A equals to 20 and trace of B is 5, then trace of A minus B is what? What is going to be? Simply 20 minus 5, that is nothing but 15. We can say directly also. Simply trace of A minus B, that is by using the property trace of A minus B is nothing but a trace of A minus trace of B. We written. Or you may ask like this, many questions we can write if trace of A comma trace of B are 20 comma minus 8, then trace of A plus B is what? This is ECET question, previous ECET question. Trace of A is what? 20. Trace of B is what? Minus 8. That is here we write trace of A plus B equal to trace of A plus trace of B. Nothing but trace of A is nothing but indirectly trace of A is nothing but 20. Plus minus 8 is nothing but 12. Plus of minus 8. But trace is going to be any number. Positive number and rule negative numbers depends upon that. You may ask. Here given the question A and B and is asking, just I am not written here, it is 2 by 2, it is 2 by 2, is asking then trace of AB. He is asking trace of AB. Simply trace of A plus B is trace of A plus trace of B. But trace of A minus B is trace of A minus trace of B. But trace of AB ante trace of AB, you will think trace of AB equals to trace of A into trace of B. But always the trace of A not equals to trace of B. You will write, you will check trace of A equals to what? 2. Trace of A equals to 2. Trace of B equals to 3. That is indirectly from here 2 into 3, 6. The options you are going to get, first option is 6, but is not going to be your answer. What we have to do to find trace of AB? He given A and B. That's why first of all you have to find AB matrix. AB matrix is going to be what? First row with first column, first element you will get 1 into 2, 2. Plus 2 into 3, 6, 2 plus 6, 8. Next, 1 into 0, next first row with second column, 1 into 0, 0, 2 into 1, 2, that is 0 plus 2 equal to 2. Next, second row with first column, 0 into 2, 0, 1 into 3, 3, next 0 into 0 plus 1 into 1, 0 plus 1 is nothing but 1. Now you have to take the principal diagonal elements. Here, trace of AB equals to, that is 8 plus 1 is nothing but 9. Here trace of AB equals to 9. See, you have to remember this, that the trace of AB always not equals to trace of A into trace of B. If we are finding trace of AB, indirectly compulsory will give A and B. To find simply this matrix, no need of writing AB matrix also. Simply if you take this elements, principal diagonal element, how means principal diagonal element means first row first column element, second row second column element. How you will get? Indirectly first row ni first column to multiply the first element astadi, second row ni second column to multiply the element astadi. Directly end element directly if you write those two elements also, no problem. Here see, one important problem is there that I am giving here, that is if trace of A equal to 6, comma trace of B equal to 4, comma trace of AB equals to 25, then trace of BA is what? He will give question like this. See, trace of AB, మనం చెప్పుకున్నాం trace of AB అనేది trace of A into trace of B కాదు. అట్లే trace of BA కూడా trace of B into trace of A కాదు. But he will give question like this. We will get confused. That is trace of A, trace of B ఇచ్చినాడు కాబట్టి trace of BA, that is 6 4s 24. First option 24 ఉంటుంది. మనం 24 పెడతాం. But one more logic given, but you have to remember that property, that is always trace of AB should equals to trace of BA. If AB, BA both are existed, why? Because trace of A, trace of B existed means it's going to be square matrix. Here AB, BA matrices exist అయితే AB, BA ఈక్వల్గా matrices అనేది ఈక్వల్ కావచ్చు, బట్ ట్రేస్ అనేది కంపల్సరీ ఈక్వల్. Always trace of AB equals to trace of BA. Indirectly what he asked, trace of BA. Here trace of AB is given, that is going to be simply 25 is going to be your answer. Trace of AB ఇది కాదు, but trace of AB should always equals to trace of BA. Indirectly your answer is going to be 25. You have to remember this property also, but I am not given in the properties, that is trace of A plus B equal to trace of A plus trace of B, trace of AB, A minus B equal to trace of A minus trace of B, one more trace of KA, it will give trace of A equal to 3. What is trace of 5A, we will ask, 3 into 5, nothing but 15, like that. Trace of KA equals to K into trace of A, right? One more, right? That is trace of AB always equals to trace of BA. You have to remember this property also. These are the problems based upon trace. You may get the problem based upon this. So many times this problem is given like this. You may ask for simple 1 mark. Okay, let's see more problems here.